1.4 without having a whole lot of difficulty. There's an algebra trick that I got to show you, but nothing too bad. So I'm looking at 1.4 today. I'm looking at 1.5 and not having a lot of trouble covering all of 1.5 in one day. Yep, I'm not looking at a lot of trouble covering that. 1.6, I'm not going to cover. I cover that in BC, but not in AB. It's the delta epsilon definition, and that is the end of the chapter. So I'm looking at probably a test next Wednesday. When am I going to see you guys? Next Wednesday, Thursday, in that kind of range. Now, for those of you that haven't been in my class before, we will stop and have a day that we talk about what's on the test, but I do not give reviews for your tests. You should know what's coming. If you don't know what's coming, we're in trouble. Like, you should be able to say, there's going to be this on my test, this on my test, this on my test. Entirely AP problems, though. So I would look at the AP sections and use that as like my rigorous study of what's going to be on your test. The goal of the class is you get a 4 or 5 in the test. Every test is based off old AP tests. So I don't give out reviews. You won't get one all year. No, you don't get one for your final. No, you don't get one for the semester test. I don't give reviews because then kids are just like, I don't have to learn anything to review. And then parents complain like there were no 7s on the review, and then you put a whole bunch of 7s on your test, and Beckman's just like hitting his head against the wall because that's not the point. Now, you should be able to figure out from my daily quizzes what I find important and what I want you to know. I'm definitely big on understanding this, not just being able to like regurgitate problems out. Today is the first time that we're going to really use an algebra trick to find the limit, though. Griffin. There's some calculator, there's some no calculator, there's some multiple choice, there's some free response. Michelle. Yep.
You know how like a 65% is like a 5 or whatever?
Yep.
Is that like the same thing?
For your final, yes, because it's over the whole year. For each individual test, no, it's just graded on the school schedule. Yeah, but your final is graded on the AP curve. Like your final you take next semester, it's an actual AP test. It's graded on the AP curve. So if you get a 5, even if that's a 62%, you still get an A. Because it's a hard test and there's a lot of information to remember. Yeah. Other questions? What else you want to know? Michael, you look like you got a question. Okay. So yes, your final at the end of this year, which you're going to take on April 19th, is graded on the AP curve. All right, today we're going to talk about sandwiches. 1.4, it is the, I keep using this one, and it keeps being dead, and I don't know why it's not dead. Why do I keep using it? 1.4, we're going to talk about trig functions. Today, and I am online, so let's go fast. There are only 2 things we know the limit of so far. We know the limit of a polynomial, which we actually only know the limit of a linear. We know the limit as x approaches a of x. Let's write that down. The 2 limits we know so far. The 2 limits we know are a, the limit as x approaches a of x is equal to a, and b, we know the limit of a constant of some constant c is that constant. Your book uses c for everything. I only use it for constant functions. I use a as the point I'm getting close to, but that's an arbitrary definition. Today we add 2 in. Well, we need to. We add 2 in. We need to expand the limit as x approaches 0 of the sine of x and the limit as x approaches 0 of the cosine of x. Sine and cosine. Okay, going back to the glory days of pre-calc. This is just a memory thing. As you get close to 0, what is sine getting close to? No, 0, right. What's cosine getting close to? 1. Y ratios, yeah, those of you having honors FST, I spent a ton of time explaining, but that's what we get from that. Yeah, those are 4. That's the 4 we're going to learn in this. Now, we take a look at a little tougher one. I brought this up earlier this year, and we'll just see what it is. What about the limit as x approaches 0 of the sine of x over x? Sine of x over x. Yes, undefined is 0, but here's the deal. We're not asking if it's continuous. We're just asking for the what? What's it getting infinitely close to? Whip out your calculator real quick. Let's take a peek at it. Now, here's the deal. Jad asked the question that I was going to lead you to, but when you plug in 0, what do you get? Undefined, but we don't care what happens at 0. We care as we get what? Infinitely close, right, infinitely close. So let's plug in y is equal to the sine of x divided by x. Now, real quick, let's go back to the glory days. I will zoom in, sorry. I will zoom in. Okay, let's go to menu real quick. We should, or mode, we should be in what? Ratings for the whole year. Now, when I go to zoom, I probably want to zoom what? Trig. Why? Because it's a trig function. So I want to go zoom trig. Now, kind of weird. What's it getting really close to? 1, which comes out of nowhere. Why is it getting close to 1? And our friend Lahopitel will explain that later this year, but that's all we look at right now. We can use the table, we can use that, but we're going to use some algebra to do that. So we're going to give a definition of this. The limit as x approaches 0 of sine x over x is equal to 1. The limit of that is equal to 1. Now, here's where I want to do that first. I think I want to talk, I'm going to see how this goes. I'm going to try it out. My brain is not as where I wish it was today, so we'll try this out for you today. We are going to look at now some algebra that involves this, some algebra. And then I'm going to talk about sandwiching. I'll talk about sandwiching at 33 after. Some algebra that involves that.
I don't know what it did.
I don't either.
Oh, I've forgotten.
Oh, I have no idea. That Casio thing's crazy to me.
Casios are wild, dude.
Yes, but I'm not. I have no idea how to operate that machine. Okay, the algebra of this. So let's take a look at an example. Example number 1 here. Let's go for the limit as x approaches, I don't know, a fun thing, of sine of 3x over x.
Nope. It's okay. I'm getting the super calculator.
Good. Now, let us take a peek at this real quick. This is a little bit trickier because it's what? Now, instead of being a really nice x, there's a what? 3. Now, we are going to go back to the glory days of Algebra 2 pre-calc for a u substitution. In other words, we are going to temporarily replace something in this. Now, going back to the properties of limits. Can we multiply this limit by a constant? Yeah, in fact, it'd be really nice if there was a 3x here and there was also a what? 3x here. So we're going to multiply this first by a clever form of 1. So we're going to multiply this whole thing by 3. We're going to multiply this whole thing by 3. I don't know why I put a parenthesis there. That shouldn't be. We're going to multiply both the top and the bottom by 3. Now, if you have not done u subs before, what u subs are used for is to temporarily replace something we do not know what to do with something we do know what to do with. If you remember, we factored logarithms by using u subs. So we're going to use u subs a lot in this class. So I'm going to multiply the top and the bottom by that. And you might say, well, that sounds crazy to me. Well, it should, because we haven't really done anything like that before. In fact, we haven't done a whole lot of algebra before this. So that gives us 3 sine of 3x over 3x. Now, notice I really like this. So I'm going to put a little box around this. I really like this. But I don't like that 3. What can I do with that 3? Yeah, make it a constant. I bring it out front. We can use the properties of limits to just move that out front. So that gives me 3, the limit as x approaches 0 of sine of 3x over 3x. Let's stop and check up. That's an algebra thing. That's an algebra trick. Stop and check up questions on that so far. That's just a properties of limits thing. Moves it out. Now that looks a lot like what we had before, except for that pesky what? 3. So we're going to use a u substitution temporarily. We're going to, in fact, I'm going to use t. I'm going to let t is equal to 3x. Now, here's what we have to consider. 3 things to consider. Actually, sorry, 2 things to consider. Boy, I wish my brain was working better today. 2 things to consider. Consider. Haha. Consider. Okay. First thing, I'm going to plug that. I'm going to replace that over here. Sorry, Hoagie. Yep, absolutely. The limit as, I'm not going to write that yet, sine of t over t. So first thing, can I replace? Yes, I can. Can I replace it? Yes, I can. I can replace it both on top and bottom. Second thing to consider, but we've also got to consider now we've changed our variable from what to what? X to t. We have to consider what's the limit. Okay, so if x was getting close to 0, x was getting close to 0, and now we're going to let t is equal to 3x, what would t be getting really close to? 0, right? Because if 3x As x gets close to 0, what's 3x getting close to? Now, if you replace it by like x plus 2, like if you had t is equal to x plus 2, if x was getting close to 0, t would be getting close to what? 2, right. So we do have to consider the variable change. We got to change both variables. So as x is getting close to 0, while t is also conveniently getting close to 0. Now, now we have something good, because what's the limit of sine t over t as t goes close to 0? 1, right? This is going to 1. We just defined that, so we have 3 times 1, and that's equal to 3 hot dog. Okay. That's going to be an algebra trick that we just use a whole bunch on our homework tonight, like homework. Not, we don't know that yet. We certainly haven't proved it.
How do you get my notebook? Nobody looked at this, did they?
I did.
Leave. Thank you. Questions on that? Ready to try an easy one or hard? Well, yes, Joe.
How did you get that 3x to a t?
Because I looked at, I can replace anything with anything. I mean, I could have let t is equal to 17. That doesn't help me a lot, but I don't like the fact that there's something here and something here that I don't know what it is. So I'm trying to bring it into a form I know. So I'm just going to basically take the 3x's and replace them with some other variable that I do know the value of. Because if I have the sine of something divided by that same something, I know as that gets close to 0, that the sine of something over something is getting close to 1. And that's just straight algebra trick. Now, I do have to at least put in your head that if I'm going to substitute something in, I got to at least consider where the limit's going. Because if this is going to 0, but I replace it with something that's not going to 0, I have to replace it with what it's getting close to. The good news is, though, as 3x gets close to 0, t is also going to get close to 0.
Right, and then you just take that 3 times 1 because 3x is on the base.
Right on. Yep. Other questions? Because the 3 becomes a constant, and then the limit's going to 1. 3 times 1, 3. Okay, easy one or hard one? I'm just asking. I'd like to do a hard one, but let's do a hard one. I'm going to start you on this and then tell you where it's going to go. Example number 2. Let's be cray. Why not? Let's go cray. Let's go for the sine of 7x over the sine of 3x. Ugh. And, oh, like, ha, 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 limit as x goes to 0. The sine of 7x over the sine of 3x. Now, let me ask you a question. If that right there was like a k instead of an x, and that was a k, same rules apply? Yeah, if that was a theta and a theta. Now, I don't like to use theta because when we think of theta, we think what? Degrees, right? We think degrees of the angle, right? I want you to think radians basically all year. But if it was degrees, the math is still the same. What's happening to the top as x gets close to 0? What's the sign getting close to? 0. In fact, that 7 is making it go to 0 even what? Faster, right? 7 times faster. And this is going to what? 0. So going back to the properties and limits, can we just split these up? No, because what's the limit of the bottom going to? 0, right? And that makes it no go. Ideas on what we could do here. Boy, it'd be nice if we had a what? Because I'll tell you, this limit exists. Constant. Oh, maybe not a constant. Let's kind of look up here. We kind of needed a what in the denominator. Yeah, we needed a variable in the denominator. What variable? Like, look at this. It'd be really nice if there's a what in the denominator of that. It'd be really nice if it's 7x. Okay, keep dreaming. We could probably put a what? In x, right. Well, what about this? It'd be really nice if there was a, like just looking at that part, it'd be really nice if there was a what? 3x. Okay, our dreams aren't going to come true, but we could probably put a what? X. So here's what we're going to multiply by. This is kind of crazy. We're going to multiply the top by 1 over x. We're going to multiply the bottom by, which is really multiplying by what?
1.
A really clever form of 1. So we're going to take a limit as x goes to 0 of sine of 7x over x divided by the sine of 3x over x. Now, here's where I'm going to leave you to now take it from here. You take the limit. Can we do that one based off of our previous example? Yeah, because there's a 7 instead of a what? A 3. And we could do this part by, well, there was a 3 on the last one, wasn't it? That 3 is going to look very similar. So I'm going to tell you, now can you split the limit of the top and the bottom? Yes, because is the bottom going to 0 anymore? No. So now we can take the limit of the top over the limit of the bottom, do what we did on the previous example to the top, do what we did to the previous example on the bottom, and ready, set, math. Ready, set, math. Ready, set, math. Then I'll talk about sandwich and we're done for today. Talk about, because we're done at 40. Ooh, we are pushing time, pushing. All right, if this helps, look up real quick. If this helps, just do this problem in two parts. We can split up the limit now. So take the limit of the top and the limit of the bottom. It's the same thing. It's doing the same thing we did in the previous example, just doing it twice. Okay, the top. If I'm just doing the top, I need a 7x on top and a 7x on bottom. All right, so I need to multiply by what? Can I take the 7 out front and a 7 inside? Yeah, I can. I'm going to do it as 2 steps, but you can do it as 1. Then I'm going to take out 7 out front, so that's 7 times the limit as x goes to 0 of the sine of 7x over 7x. On the bottom, I'm going to multiply by top and bottom by what? 3 over 3. So I get 3 limit as x goes to 0 of sine of 3x over 3x. Now, could I show with a u substitution? Yes, I could, but what's the top going to go to? 7. What's the bottom going to go to? 7 over 3 hot dog. Now, I'm showing you the work I expect you to show. I can get that this limit's equal to 1. I can get this limit's equal to 1. I do need to see that step right there, though. Let me ask you a question. If you're scrunched in between 0 and 0, where are you? If you're scrunched in between 0 and 0, where are you? You're at 0. Okay, that's the last thing we're talking about today, ladies and gents, is the sandwich theorem. That's where you are sandwiched in between two things. Like, oh, yes, you've got 2 dates. They're both making bad choices. They're both making bad choices. So they're both going to King's office. Where are you going if you're scrunched in between them? King's office, indeed. This is called the sandwich theorem. Literally. So the sandwich theorem says, if f of x and h of x have between them g of x. And the limit of both f of x and h of x, oh, yeah, I better keep it generic as x goes to c. So the limit of both h of x and f of x is equal to some limit L. Therefore, the limit as x approaches c of g of x has to be equal to what? C, right. If h of x and f, h and f are both going to L, and you're between those two, you got to be going to L too. Yep, L, yeah, equal to the limit. Okay, so let's look at an example of that. So then they throw this dog at you. And this is the classic math example. X goes to 0 of, what do we got here? X times the sine of 1 over x. And notice I'm switching colors real quick. This looks nasty. But we have to ask ourselves, does it matter? It looks nasty. And I am going to finish this one. I may have to take a minute of your lunch. I'll give it back to you. This part looks nasty, but we have to ask ourselves in calculus, does it matter? Does it matter? Well, here, let me ask you a question. This, at most, is going to be equal to what? The sine of anything at most is going to be equal to what? 1. At least it's going to be equal to what? No, worse. Could go all the way down to -1, right? Sine oscillates between 1 and -1. So this right here goes between -1 and 1. Well, let me ask you a question. If you multiply -1 by x, what are you going to get? X. So at worst, this is going to be -x. At best, what's 1, the biggest value this can be, times x? X. So we know that this is somewhere between, yes, I can, these two values. Would you agree with that? That this nasty thing I threw at you, at worst is -x, and at best is +x. Now, why is that? Because the sign's biggest value is what? 1. The sign's lowest value is what? Okay, now let's ask a question. Let's go back to that theorem. So we said g of x, our nasty thing, is between these two. Let's look. What's the limit as that goes to 0? What's the limit as that goes to 0? So what does that limit have to be? There you go. That's using the sandwich theorem. So I will write one more step. Yeah, you can go back and watch it if you want. Oops. I forgot to write limit in there. Pretend I wrote limit. Let me rewrite it. That's what I get for doing fast and sick. Yeah, I will text you the homework. Because both of these are going to 0 and this one's in between. Therefore, the limit as x approaches 0 of x sine of x, sine of 1 over x, is exactly equal to 0. If you're a football player and you were gone last time, show me your homework. If not, have a wonderful day. I will text that homework. You will have to read just a little bit. I didn't quite get as far as I needed to today. What's up, Miss Givens?
How are you?
I'm outstanding. How are you?
Good.
You enjoying another year of Breebach, or who you got?
I have Rainford.
4?